Today's light sources include incandescent lamps, gas discharge lamps, called xenon, and LEDs. But only in combination with headlights of various designs can you obtain lighting that ensures comfortable and safe driving. Thus, the low-beam headlights of the BMW 3E30 with a small lens were equipped with an efficient and high-tech H1 lamp for its time with a luminous flux of 1550 lumens. But such a bunch of lights shone weakly. Another car of the same period, the Volvo 240, used a less efficient H4 lamp in the low beam. Excellent road illumination was provided by the large reflector surface. Today, technology allows us to create headlights that are both attractive and efficient. However, the production of high-quality optics entails high costs, which are considered unnecessary for most budget cars. It should be recognized that manufacturers are constantly investing in lighting fixtures. A big breakthrough was the appearance in 1993 of H7 lamps with a larger bulb than the H1 and a high luminous flux of 1500 lumens. A good headlight reflector equipped with such a light source provides uniform illumination over a long distance and a soft boundary between light and shadow. H7 lamps have been criticized for their low durability. In this technology, no one has come up with a better compromise between efficiency and production costs. Even earlier, in the late 1980s, several companies, including BMW, Hella and Bosch, began working on the use of discharge lamps in automobiles. The result of this cooperation was the extremely expensive xenon, offered for the first time in the BMW 7 in 1992, optional. This circuit had a characteristic design, a gas discharge lamp marked D1 and a metal box at the rear of the headlamp the size of a brick. The lamp power supply system was located there. The next generation of BMW 7 used different gas discharge lamps, DS1, which are widely used today. I have good news for you. Now, if you are planning to buy a used car, or learn more about your car, you no longer need to search for the information you need on the internet. We have collected everything in one place for you, on the website carme.pro. Here you can find out everything about the car, what breaks and at what mileage, any problems with engines, chassis or gearboxes, which trim levels are better not to mess with and how not to lose money buying a used car. You will learn all this on carme.pro. Xenon lamps represent a premium level in the field of lighting technology. They have become a high-value option in even the most expensive cars. The high cost is due not only to the need to use more expensive lamps, supplemented by coils and converters, but also to mandatory equipment such as automatic light level control and headlight washers. The requirement to install a light corrector and headlight washers, which appeared around 2010, does not stem from the presence of xenon light, but is tied to a glow power exceeding 2000 lumens. The most powerful halogen lamp H9 has a luminous flux of 2100 lumens, and the H7 lamp has a luminous flux of 1500 lumens. Since gas discharge lamps in 2010 had a power of 35 W and a luminous flux of 2800 to 3200 lumens, their use forced the installation of additional expensive equipment. Lighting manufacturers, in response to demand, decided to bypass the requirements that applied to xenon headlights and offered lower power discharge lamps, reduced by almost 30%. Gas discharge, xenon, lamps such as D5S and D8S, unlike older types of xenon, have not 35 W, but 25 W and a luminous flux of not 3000 lm, but only 2000 lm. This is exactly what the standard allows to be placed in the reflector without additional equipment. When it comes to savings, the 12V D5S lamp is a masterful achievement of technology. The sale of such a lamp in car headlights costs the same as H4 incandescent lamps, and it can be sold as a necessary and expensive option, xenon light. Application examples: Citroën C4 Grand Picasso 2, Opel Corsa E, Skoda Spaceback, Audi A4 B9, Audi Q7, Audi TT, etc. The validity of this concept is based on the fact that a buyer moving from an older and outdated car will not notice anything. He will enjoy the xenon light and think that there is no better lighting. But the fact that objectively the lamps shine like headlights from H7 or even worse is another matter. The use of an LED module in low-beam headlights is a completely different level of complexity than in the case of xenon and, at least at the initial stage, required significantly higher production costs. The low-beam module in an LED headlight consists of several lighting elements, which makes it difficult to obtain uniform illumination and a smooth border between light and shadow. Temperature is also a significant problem. The LED module does not heat up forward, like light bulbs or xenon, but backwards, heating the plate to which it is soldered. Since LEDs are very sensitive to temperature increases, it is necessary to use radiators that cool them. The higher the temperature, the lower the service life of the diodes. Additionally, a hot LED produces less light than a cold LED. This raises an additional problem, the need to heat the optics in winter so as not to freeze up. That's why some LED headlights have a heat distribution system. It cools the module itself and at the same time heats the glass from the inside, ensuring moisture evaporation and ice defrosting. The entire reflector consists of multiple light segments that can be turned on and off quickly and smoothly. In the most modern designs, the system is controlled using cameras that monitor glare and oncoming objects. Individual elements are switched off to avoid dazzling oncoming drivers. In such designs, outside populated areas, it is possible to constantly use high-beam headlights, which are automatically switched off completely or partially. In addition to LED lights, manufacturers must install headlight washers if the luminous flux of the low-beam segments exceeds 2000 lumens. The illumination range can be adjusted depending on the driving speed. LED technology opens up enormous possibilities. An electronically controlled multi-segment headlight, such as in the Audi A8, works with a system of sensors that react to the reflected light falling on the car and control the individual headlight segments, which smoothly dim and brighten. As a result, the driver has a brightly lit road in front of him with minimal glare to other road users. As speed increases, the range of low-beam headlights increases, but at city speeds it decreases. After turning on the high beams, the driver does not feel any discomfort associated with the light reflected from reflective elements in front of the car, for example, road signs. The Lexus LS 600, introduced at the end of 2006, became the first production car to be equipped with an LED light source for the low beam, side lamps and side lamps. The high beams worked on halogen lamps. How do LEDs actually work? Take, for example, the Seat Leon, a compact car that, in most versions, is equipped with full LED lighting. The light seems promising, but is actually average. The biggest disappointment comes after turning on the high beams. The light is reflected from the road signs so strongly that after switching to the near one, darkness sets in for a moment. It is better not to use high-beam headlights, especially in rainy weather, more glare. Or Volkswagen Golf LEDs. Low-beam headlights have a short range, and the boundary between light and shadow is so sharp that beyond it there is only darkness. And in the Jaguar XF, the LED lights are just dim. Conclusion: LED headlights shine differently and do not guarantee better illumination than a good halogen. Many LED headlights burn worse than mediocre H7 headlights, and the vast majority are certainly weaker than 35W xenon headlights. But this is not surprising. No rules require full LED headlights to shine better than reflectors designed 30 years ago and equipped with the good old H4 bulb. Manufacturing cost, weight and headlight volume are currently major issues in the automotive lighting industry. In each of them, the advantage of LED headlights is quite disruptive over other solutions. If we talk about production costs, then, for example, Renault's all-LED headlights in 2014 cost 4 times more than headlights with halogen lamps and LED running lights. But 2 years later, with the advent of the next generation of LEDs, the average cost of an LED headlight dropped by half. Today, production costs are almost equal to halogen headlights due to the reduction in the amount of plastics used in production. The cost of plastics is about 30% of the total cost of a headlight. LED headlights take up less and less space, the housing becomes less bulky. These features guarantee them a bright future.